Hello everyone, this is Hidayat Shahid. I'm your lab instructor for MECE2310U Concurrent Engineering and Design course. In this video, I will walk you through your lab manual 5, where you will be introduced to how to use some of the simulation tools which are available in SOLIDWORKS, which can be used to perform finite element analysis. That can be very helpful to do the design work. Having said that, I would like to emphasize one thing, that in this lab we are not providing you any training on the mathematical modeling or the proper background in finite element analysis. In order for one to understand the finite element analysis, they need to have the background in number of areas. Some of the areas are basically that you should understand the partial differential equations. You should have taken solid mechanics course. You should understand the mechanics of materials. You should understand the numerical analysis and utilization of various techniques. So there are a number of things that you will be taking, number of courses that you will be taking at Ontario Tech, that will help to build that knowledge as you move along your program of study. So basically, I just want to describe a few things before I move forward. The number of steps that are normally required to do finite element analysis: you basically, first of all, you define your geometry of the problem, then you assign some materials, and then you create a mesh. Basically what you're doing is you're dividing your larger object into small components, and then basically on that object you're applying the law of physics. For example, it's conservation of energy, conservation of momentum, and then you're tying those down with the material behavior and other constraints such as compatibility and others. So basically in this lab exercise, what you're doing is you have this disk which you have created in your previous lab exercises. On this disk, all you're doing is you're performing a finite element analysis, where you're applying external load on this disk. The external load is basically it's a torque. What you're doing is you're fixing the this hole, and then you're trying to rotate this with the known torque. And as external load is applied on your disk, obviously this disk is gonna resist, and the resistance comes from the internal forces, which results into stresses within the structure of your disk. So we will be basically looking at fundamental tools which are available in SOLIDWORKS, and then we will do the analysis, and then we will extract some results which are useful to do your design work. So to start this lab exercise, the first thing first, what I would like to do is you should create a folder, lab 5, and then from Canvas, where we are providing you this part model, it's named as lab 5 disk A, or simply disk A on Canvas. So please download this part model and save it in your lab 5 folder, and that's where you will be working in. And the first thing that I'm gonna do is I'm gonna open up this a file. The next thing I'm gonna do is there is the simulation tab which is available. This is where you basically can start your exercise. If this simulation add-in is not activated on your interface, you can go in here, and there will be, if you go down in here, it's add-ins under tools. In here you can select the add-in tools that you want to bring it in, and I have already checked in my simulation. So I am just basically gonna click OK. What I normally do is I disable the packages or the add-ins which I don't need, which I'm not working on. and this helps to whenever you are loading SolidWorks. It basically speeds up the load up process. So to start the study for the finite element analysis, I'm going to click on this new study. It's basically brings this dialog box. In here, you can specify what kind of study you want to conduct. You can do the thermal analysis. You can also do CFD as well, but for CFD you have computational fluid dynamics. You have to bring in the that tool from there. For this analysis, all we are doing is a basic static problem. That's what we are solving. So I'm gonna click OK. As soon as I clicked OK, so this in the feature manager, this feature manager has been added associated with the study. In here, things are laid out in a very in the order that you have to define things. The first thing I will do is I will define the material. All these parameters which we are setting in here, they can be accessed from these toolbar as well, or you can right click and you can click on connection advisor and other things, and you can set the constraints. So I'm gonna apply the materials. According to your lab manual, the material for this study, which is specified in figure 7, it's 6061 alloy. So I'm gonna find 6061 alloy, which is under aluminum. So there is 6061 alloy. As you can notice in here, when you're selecting this, basically you're setting the material properties, and these material properties are associated with this material. SolidWorks and other software packages, they normally commercial ones, they provide you some library, built-in library. However, you can also define your own materials if you have some experimental data and so on and so forth. So for the purpose of this exercise, I'm going to leave everything as default, and you can verify some of the materials on back of your material science book. Whereas elastic modulus is this, Poisson ratio is 0.33. I'm going to click OK. So the material has been applied, and the next step is basically you can go to this Fixture Advisor. If you click on this, it basically guides you through what you need to add, what you can do. And it provides you some basic description of the constraints that you're applying. You should do a reading on every constraint that is available on the in the SolidWorks when you're using it. So what I'm gonna do is I'm gonna just basically go in here. I'm gonna do fixed geometry, which is on the left side. Is showing you what basically this fixed geometry means. If I select, for example, this face and apply the fixed geometry, all I'm doing is I am basically locking any movements around this face, so it can't rotate around it, the axis. It can't move in XYZ direction. So that's what basically it is. I'm locking all the degrees of freedoms associated with that face. So I am basically going to apply that constraint on it. That is applied. The next thing I'm going to do is I'm going to apply is the load, and which is the torque. And I'm going to go right click there. I'm going to select torque. For the torque, I need to provide the information that which axis it's going to be applied on, and also the edges, faces, where the torque is actually applied. So in here, basically, when specifying the torque, in here, I'm gonna go select this face. So basically, it's applied at the center associated with this cylindrical face, and the actual torque itself, I'm gonna pick this face. And the direction of this, you can change it, you can reverse it if you want, but for the purpose of the exercise, it doesn't really matter which direction it goes. If there were other components attached to this part, then the direction would make a difference. To change the direction, all you just gotta do is check this box. So the value that is needed for this step, it's specified as 150 newtons meters. And I'm gonna click OK. So basically, these are the two constraints. One is basically the external load, which is torque I have applied, and also I have fixed this. The next step is basically to divide this disk into small sections. How to do that? So basically, for that is referred as meshing your dividing your computational domain by discretizing it. So what I'm gonna do is I'm gonna click mesh, and I'm gonna say create mesh. So in here, you can control your meshing parameters, or you can do the basically changing this slider. You can specify your mesh size there. The specification, which is specified in your lab manual step 9, it basically says set the units for the global element size, set them as 15 millimeters there, and then the tolerance, it's 0.75 millimeters. And if I click OK, it basically creates the mesh around your object. Okay, so the next step is everything is defined in here that is needed for the analysis. What you can do is you can run this study, and in here, whenever you're running any study, it's basically solving the partial differential equations, and it's basically determining an approximate solutions to the physical problem that you have, that you're trying to solve. So in here, as results, it has basically calculated the stresses, which are due to the external torque on it, and you can also see the deformation of the body in your the displacements and so on and so forth in your disk. There are a number of things that you could do with these results. You could change the settings. You can change different variables in there, how you want to present your results. You can animate, but these are highly exaggerated simulation. In reality, the deformation won't be that extensive. In your lab manual, the next step, basically what it does is ask you to refine your mesh and make it smaller mesh. So basically, the accuracy of your whenever you're doing finite element analysis, there's two studies that you always have to do. First of all, you need to validate your model, the numerical model that you're trying to solve a physical problem with. You need to have grid density study, which is basically you change the mesh sizes to the level that the results don't change to some acceptable level, which you define. Now basically I will just show you how to change the display settings for your results. You could right click on it, you can change the definitions by clicking on it, and then you can change the parameters here. Now I will move on to the next step. Next step basically requires that I create a new study. I'm gonna create a new study, and I'm gonna leave this as static, and this second study has appeared here. So what I'm gonna do is I'm gonna create follow the same steps. I'm gonna add apply material. In this one, this is alloy steel, that's what it calls for, and I'm gonna apply that material for the study. I'm gonna close this dialog box, and I'm gonna go to the Fixture Advisor, and I'm gonna fix the geometry. In the geometry again, I'm gonna select this face, and I'm gonna fix all the degrees of freedom associated with that. And then I'm gonna apply the external load, which is torque. I'm gonna select this face where the torque will be applied, and this face which will pick the center axis for that. And the value of the torque for this study, it's 200 Newton meters, 200 Newton meters, and I'm gonna click OK. The next step is I have to basically create a mesh, and to create a mesh we're gonna solve this mesh with the different setting with the finer mesh size. To do that, basically you have to do is create a mesh. I'm gonna right click here, I'm gonna click on create mesh, and in here I'm gonna specify the mesh parameters. I'm gonna specify the size as 5, and the other setting I'm gonna leave it as 0.5, and I'm gonna enable this automatic transition. For the previous study when I did it, I had included that in, but the lab manual you can have the run one study with without checking it, and you will see the mesh sizes are different. So I'm gonna just show you that. I'm gonna uncheck that, and you see the mesh has been created with more or less equal size. But what I want to do is I want to have a more refined mesh when the where the object has transition, and there's the size is getting smaller. So to do that, I'm gonna go back, and I'm basically gonna do is create the mesh again, and I'm just gonna select that. I just want to show you the impact. Just pay attention over here how the mesh will be transitioned. I'm gonna click OK. So as you can see, it has created more refined mesh around these features. What happens is whenever you have changes in the geometry about corners and stuff, in order to get more accurate results, you need to have the finer mesh. That helps you to avoid any major changes in the stresses, or the to pick up the stress concentrations around those features of your object. So I have pretty much defined my study. So what I'm gonna do is I'm gonna basically hit this run this study, and while it's solving it, so basically this is the solution, and then you can play around with the various settings, how you want to display your results. You can probe different values for stresses and displacement and so on and so forth. So for the purpose of this lab exercise, your lab is complete. Basically for this one, please save all your files. So yeah, before I stop this video, I would like to show you a couple of things that you could do which are not covered in your lab manuals. For example, in here, the folder where I have saved all my files associated with the lab 4. Whenever I ran the study, it basically created another folder associated with that study, and all the the files which are associated with the solution, they have been saved in that folder. So when you're uploading your file for on Blackboard, please make sure you zip the entire folder and keep all the files in. Without those files, we will not be able to verify or open your study. Another thing that I just wanted to show you is this. SolidWorks can create report for the users. So I'm gonna create a Word report associated with the studies, and I can select what I wanna include in the report or not. I can specify who's the designer and so on and so forth. And after that's done, what I'm gonna do is I'm gonna basically say publish, and it's creating a report, which is extremely helpful because it covers everything. It defines all your applicable conditions, your boundary conditions, your mesh sizes, your materials, your the loads that you have applied, and other constraints that you have applied. And you should always verify your results by documenting things properly. So let's have a look at the report that the SolidWorks have just created. It basically describes your model. It describes the settings for the studies that you have specified, materials, loads, fixtures, and also it includes the results. Let's just quickly have a look at the report. For example, the first page is showing the geometry, what the mass, volume, and so on and so forth, and then it specifies what type of study you have conducted and what kind of settings you have used for that study. And anybody who wants to read through these settings, you can provide the additional documentation associated with SolidWorks, how it's defining the study. In here, basically, it sets the units so the reader can read through that, and you're specifying in this report the material properties which were used to conduct the study. And it defines where the loads were applied and the values associated with as well, and the reaction forces which were basically obtained, and then basically it specifies what solver it used to generate the mesh for your object. And it specifies how many number of elements were in your mesh and how many nodes were in your mesh. Nodes are basically the connection between two adjacent elements which are sharing the nodes. And then basically it shows you the mesh so the reader can have a look at it, and then you can present your results in this report. So basically then you can actually also modify this report to add whatever you want to add. So this is a really powerful tool which puts out the data in a really nice fashion that can be presented to your audience. So this basically concludes your lab 4. Thank you very much for watching this video.